Well, hi, thanks for joining me as we take a look at practice problem number 3. Before we dive into this, I'm just going to say something like this actually would work really nicely for like an IA project. So if you're someone who likes sports, and maybe you have some favorite teams, whether that's soccer teams, basketball teams, baseball teams, football teams, volleyball teams, whatever teams, or even just people in general. I don't know, golf or tennis or bowling or whatever sport you're into there. Doing something like this absolutely is fair game to kind of make an IA out of. So, kind of a cool thing we got going on here. In any given season, a soccer team plays 65% of their games at home. We could look at this from the perspective of the Spurs if we wanted to. When the team plays at home, they win 83% of their games, because Spurs fans are really awesome like that. And when they play away from home, they win 26% of their games. The team plays one game. So all we know is the team played a game. We're not sure where they played. We don't know if they won. We're going to try and figure out the probability here. So this is kind of like if you're looking at their schedule and you just like randomly pick a game off your team's schedule. We want to know what's the probability your team is going to win the game. Well, one of the first things I notice right away is this problem does not give me any visuals to work with. There's no Venn diagram, there's no tree diagram, there's no two-way table, I got nothing. So what this means is I have to make my own image. So if I'm looking at this and I'm thinking, okay, I've got games at home, and then when they play at home, we talk about winning and losing. So something like this, something where I have this sequence of events, I do one thing or I look at one thing and then look at the other thing, that gets me thinking along the lines of a tree diagram. So I've got to build my own tree diagram. So I'm going to make my little branches. Here's a branch. Here's a branch. What's the first split that we're going to have? Well, notice in order to figure out whether a team wins or not, we need to know whether they're playing at home or not. It's not like they play the game and then we see if they win. They have to play the game first. So we can have them playing at home, and I'll use H for at home, or not playing at home. And the probability that they play at home is 0.65, which means, if you think back to the key concepts that we talked about, what's going to be the probability that they do not play at home? Well, that's going to be 0.35, because remember, these two have to add up to 1. So now, once we know whether they're playing at home or not playing at home, now we can start talking about whether they're going to win or not win. Now, if you want to use W and L for win and, see, I'm about to do that, right? For win and lose, that's fine. I'm going to stick with the notation, that little apostrophe there that means not, just so we can get used to that as notation. So win and not win. Okay. Well, so let's see. When they play at home, they win 83% of their games, which means what percentage of their games do they not win? That's going to be 0.17. When they play away from home, they win 26% of their games. Now, one thing I'm going to point out is notice I'm not using 65, 83, and 26. I'm talking about probabilities here. Probabilities have to be between 0 and 1. If I try to say the probability of playing at home is 65, that's like saying 6,500%. That's not a thing. So we can't use whole numbers when we talk about probabilities. We have to use either decimals or fractions. I would even be careful using percents, because when we start doing calculations, you're still going to have to turn those percents into a decimal or a fraction. Might as well just do it now. Okay, so this is the image that I'm going to work with to help me out. So now, let's look at part A. Find the probability that the team wins the game. Okay, so what do you notice about wins? Look at our tree diagram. What do you notice about W? hopefully you're noticing there are two of them. Notice there are two W's. So we're going to need to take both of those paths into consideration. We can play at home and win, or we cannot play at home and win. So this is going to be, we can play at home and win, or we cannot play at home and win. So let's take this little sentence using ands and ors and let's convert it into numbers and symbols. What's the probability we play at home? 0.65. And means multiply. Win is 0.83. Or means add. Not play at home is 0.35. And, add there, multiply, 0.26. Now, in some of the work that I saw some of my students doing, a lot of people were annotating and doing the work up here, which is totally fine if you want to do your work up on the tree diagram. That's a strategy you can use. I'm going to stick with it down here, though. And so when I do this, I'm going to get 0.65 times 0.83. I got 0.5395 plus, and then 0.35 times 0.26, I got 0.091. Adding those together, and I get 0.6305. So the probability of winning is 0.6305. Okay? Well, so now let's look at part B. I want to know if the team does not win the game, find the probability the game, oops, can't even see here, sorry. If the team does not win the game, find the probability the game was played at home. Very sneaky. Notice if the team does not win the game. Well, here's the thing. Are we wondering if they won the game? Are we sitting there going, what's the probability they win the game? No. We know they did not win the game. That's not up for discussion. We know that didn't happen. So this is actually a way that we have a given piece of information because we are told that right off the bat. That's not in question. So what part B is actually doing, we want to know what's the probability the game was played at home given the game was not won. Okay, so let's take a look at this. Well, my formula tells me that this is the probability of home and not win divided by the probability of not win. This comes straight from the formula off your formula booklet, or the one that I talked about in the key concepts at the very start, or the very start video of the notes here. Okay, so home and not win. Well, let's see what we got. I need to play at home and not win. So I've got to follow both of those paths. So I'm going to have 0.65 times 0.17. Now, the probability of not win. Here's the thing. I'm going to use what I've already got to help me out because I know win and not win, those are complements. Those are the only two possible outcomes that could happen. You either win a game or you don't win the game, which means that they're going to add up to 1. So I'm going to use that to save myself some extra work here. And I'm going to say, okay, I know win plus not win has to equal to 1. Notice I already found win in part A. So I'm going to use that to help me and save a little bit of work. And I'm going to say 1 minus 0.6305. And then I'm going to plug this into my calculator. And when I plug this into my calculator, I'm going to get 0.1105 over 0.3695. And when I do that, give me just a second here. One sec. I'm going to get 0.299. Okay, so the probability that a team played at home given they did not win? It's basically 30%. I'm going to leave this because that's 3 sig figs. So there you go. If you have any questions on this, or if you have any concerns, please feel free to reach out to myself, Miss Ascott, or to Miss McDougall. We are both here eagerly waiting to answer your questions because we're teachers, and that's what we love to do, and we miss you, and we miss being able to answer your questions in class. So please reach out if you have any questions. Thanks so much.